Listen, your thing is done.
Yeah.
What do you mean what thing? That lock, that broken thing.
Oh,
Look, whatever. Listen, I know it was 2 years ago, but I need it for one more day. Oh, so you saw the video, huh? No, you're not getting it for free now. I'll have you know 1 or 2 people actually enjoyed that video. Why do you always have to be such a jerk, Harold? It's important to me that you know that I'm not screwing around here. Scout's honor, I'm busy buying some time. Unfortunately, a lot of questions came out of my filler video. I say unfortunately because when you get the same few questions so many times on such a short video like that, well, frankly, it means I'm not doing my job right. I let some of you down. What is that thing? What does that thing do? Where's the oil port? I can't believe you forgot the oil port. Hey, winky face, what are you wearing? And you're totally right. I dropped the ball. I've ended up with a delightfully varied audience, and sometimes I take things for granted. But hey, I'm still at least 65% human, right? Often, when I'm out in the garage, I'm wearing my black sweatshirt. And nothing else. And this? Well, I'm not 100% sure what it is. I'm pretty sure it's not carbide lipstick or a giant pen. It looks to me like a spring-loaded locking detent. And I say that for 2 reasons. First, it looks like a spring-loaded locking detent, so there's that. And second, the guy said, hey, one of the locks broke on our mortiser, mind having a look. Evidently, I'm a regular Sherlock Holmes. And I thought about calling Harold to ask for more details. Regrettably, our relationship isn't quite what it used to be. At this point, now that it's finished, the only reasonable and mature option is to leave it on his doorstep, ring the bell, and run away. So this is a spring-loaded detent, much the same as these. These are my 3/8 inch and 1/2 inch ratchets, socket wrenches. As I'm sure you know, they use spring-loaded balls to detain the sockets, like detention. They're ball detents. And this thing just uses this wedge-shaped plunger, but it's the same concept. Of these 2 wrenches, the larger one, the 1/2 inch one, is not a locking detent. You can push the socket on, you can pull the socket off, you can shake it all about. It's calibrated from the factory with some amount of retention force. The smaller one is a locking detent. It's got a button on the back. In order to release a socket, you have to push the button that drops the ball in order to get the socket off. This thing has a lever. So in one position, it's kind of sprung, and in another position, it's locked. It's sort of locked out the spring force. This is installed through a hole or a bore in a piece of equipment. The detent sticks out one end, interfaces with the part you want to stop or start, detent or not detent, and this sticks out the back. Now, detents usually work in shear. That means whatever you're trying to stop is pushing, perpendicular to the detent itself. So any load on this should try to break this hardened pin. And that's why I was surprised in the last video to see it had broken inside the corner here where it was installed, leading me to believe somebody stepped on this or ran into it with something. Now, the reason I'm not 100% sure when it comes to this is that it doesn't work how I'd expect it to work. Personally, I think it's missing some parts. Like when it broke and they scrambled around on the floor looking for all the pieces before the boss saw what happened, they didn't find them all. Assembled this way, the detent and lock sort of work the way I'd expect. But the lock or release or whatever this is doesn't quite work right. And there's a lot of slop. In fact, I think it's not working right, or I assembled it wrong, or it's missing pieces because of that slop. Now, this thing has a beefy spring in it. We'll see it in a minute, but you may recall it briefly from the last video. And I've installed it in the front. There's a neck down area right in here, smaller diameter, and I've got the spring in front of it. That allows the plunger to spring back to do the detenting. Let's knock this down. On second thought, let's make our own spring-loaded ball detent first. That might get us talking the same language. Here's what we've got. 2 small metal spheres just out of an old roller bearing, a piece of 3/4 inch cold rolled steel, 19 millimeters. Got that from my scrap bin. And 2 small springs. I just picked a spring that's slightly smaller in diameter than the ball. For this, I'm not really worried about the spring force. A good source of small springs might be an old clicky pen, or in my case, a yellow number 2 pencil. A normal person would just buy a ball detent and install it. But we crossed that line a long time ago. Detents or spring plungers are available commercially, of course. Find one of the right size and the right force for what you're trying to do, and you'd install it like any other piece of hardware, a nut or a bolt. This is just for kicks, under the guise of demonstration. I'm going to try to make 2 different styles on the same piece of stock, and we'll talk about them. Let's see if you can't pick up on what I'm laying down here. You saw me drill and ream this first hole. This isn't a through hole, and it's reamed for the size of the ball. It just fits in there. That should have actually dropped to the bottom. I should have blown that hole out. But it's not a through hole. The second one is a through hole, except the exit diameter here is just a little bit smaller than the ball. So it fits in the other side, but can't make it all the way through. It could make it, 30 or 40% through. And I've also cut some threads in the backside. This allows me to build up the detent with the ball, a spring, and a small set screw, like a grub screw. Now, because of the combination of ball size and the stock that I'm building the detent into, between the ball, the spring, and the set screw, I'm starting to run out of space, so I counterbored it. Spring sits in the back of that counterbore. It does help keep it centered, but more than anything, it's given me back some space. This should make sense in a minute if the light hasn't come on yet. Let's install the blind detent first, simply because this will be a little more violent. So the spring would go in first, and the ball in behind it. So it should be obvious now that there's nothing that keeps this ball inside of this bore. What I'm going to try to do is push the ball down in there and peen the edges over, like upset some metal, create an interference, and then hopefully the ball is retained. It doesn't come shooting out of there and take out my one good eye. In real life, this operation would be done in some kind of a press, with a jig that holds the ball down, and then the ram comes down and swages the edge of that hole nice and consistent. Or more than likely, there'd be like a counter bore at the top. You could put the ball in and then press on a ring that's an interference fit with the shaft and doesn't let the ball come through. But I'm just going to try to have at this with a hammer. What do you think the odds are I don't drop this? Okay, not the greatest looking thing in the world, I'll give you that. But in my defense, these parts are kind of small. I mean, for reference, one human hair is only about... This other one, in contrast, is a lot easier to get together. Now, the second one is a lot prettier, isn't it? It looks like I could have gone a lot deeper with the counter bore, like left less material so the ball would protrude a bit more. This one I should have only peened the high spots, like the high spots of the round. That's what you get for not thinking ahead. For having rushed through those, I'm pretty happy with how they turned out. Now, the hole in my bench isn't exactly precision, so the made-up isn't as satisfying as it could have been. But, it detents into place, sort of does its job. Now, what we built here is, I don't know what you'd call it, a fixed force detent and an adjustable force detent. This was the one in the blind pocket, and the force that takes to do its thing is dictated by the strength of the spring, how much compression is on it, how much that ball is sticking out, how much that ball interferes with the hole I was trying to push it through. Not necessarily a long list of things, but it's fixed. This one, on the other hand, has a screw on the back that gives me some control over that spring force, allowing me to make the detent softer or harder. In fact, if I push that screw all the way in, that wouldn't detent at all, turning it more into a lock maybe. Though obviously once that thing is detented into the type of hole we saw on my bench, I wouldn't have access to that screw. Now, spring detents, generally speaking, pop up everywhere. My socket wrenches use the same trick, using a ball detent to retain the sockets. These are both fixed force, set from the factory, and this smaller one has another trick up its sleeve, where the ball can't really move unless you push the button. You can imagine maybe some pin coming through here with a step-down diameter that interferes somehow with the ball and the spring, just like the screw in the other one, except it's screwed all the way in or all the way out, locked or unlocked. But have a look at this thing. This is my torque wrench. Still a ratcheting socket wrench on the business end, But inside this long tube, it's got fundamentally the same thing. There's another detent up here where this pivot is, where you see that pin, a long spring, and a screw, which is this handle. I can change the detent force at the head by turning this screw in and out, by turning the handle in and out. And in fact, it's even got a calibrated scale. This spring tension here adjusts how much force this detent takes before it breaks away, which is directly related to the torque I'm putting on maybe the fastener. Some of you may recognize this thing. This is a General brand car stereo steeling tool, also sometimes used as a spring-loaded center punch. And this is a close cousin to some of the spring detents we've been looking at. Again, there's a screw on the back that adjusts the spring, with the difference that there's another part in here. When the spring tension gets too high, it trips over and lets go, transferring all that spring force into an impact at the tip. Right about now, you might be wondering what the point of all this is, perhaps questioning the necessity of me having built 2-ball detents and talking about my torque wrench and center punch. Well, let me put it to you this way. You're right. Let's get back to the project here. Yellow.
Oh, yeah.
It's a quirky way of saying hello. What do you want? Well, I recall you saying that it stunk, and you're calling me to tell me you watched the video again? Oh, come on. You didn't even know that oiler was there. For the last time, Harold, you're not getting it for free. Here's what we got. Not too much going on inside. The detent itself, like the lug that interfaces with the divot or the hole or whatever that goes into, it's on a threaded tie rod, and there's this sort of yoke at the end with a cross pin. And of course we have a spring, and it's quite a beefy spring at that. This here is the lever we saw from the outside, and I assume that interfaces with that pin. The lever in turn is pinned to the body with a little spring pin, little roll pin. And I assume as you turn that lever, it pushes the detent forward or pulls it back. Seems pretty straightforward so far, right? Now remember, there's a reduced section in the body. There's the shoulder, tight spot, where this spring butts up against. If this spring is ahead of that section and it butts up against the back, it gives some spring force to the plunger, in and out. If it's behind it, that's the way I got it, with the spring installed behind that shoulder, it's providing a spring force out of this body. Opposite, I guess, what you'd expect from a detent. And the odd behavior of this thing, depending on how you install the spring, is the reason I'm not 100% sure about it. Like, it doesn't seem to work the way I'd expect it to work. Personally, I think it's missing some parts. But I don't want to ask you to take my word for it. Let's assemble these parts and see what it does. And to address maybe the inevitable speculation that I just didn't make this part right, we'll build it into the original body. But just for the record, this whole YouTube channel thing might not work out if you and I are dealing with trust issues. So I'll assemble this with the spring in the back, just the way I got it. So this is how I got it, without this little drill bit, of course. This just saves me the trouble of pounding this pin in and out. The problem again was that the mounting boss had broken off. So assembled this way with the spring in from the back up against the shoulder, the plunger has no compliance. It's one solid piece through the tie rod, through the yoke, and to this cross pin. And if I pull the lever, it tries to push that pin out. In addition, I can't get the lever up very high. No amount of adjustment of the tie rod inside would let me do that because the spring goes solid and the tie rod's too long. Not to mention that this little lever/button, to me, strikes me as the pushy type, not the pulley type. It seems like you'd want to push this down to do something instead of trying to get your hands under here to pull it up. Now let's try to install it with the spring at the front. Assembled this way, I now have some compliance in the detent, and pushing the button retracts the tip. So this way you can adjust the amount of spring force and the length of engagement and use your piece of equipment or whatever this thing is doing. When you need to make adjustments, you push the button, move the equipment, let it go. The problem here is that this thing has a bunch of slop in it now. If the cross pin isn't in the yoke, it can jam up. Maybe it's supposed to be installed under pressure via this collar. That's what keeps it all together. It smells a little fishy. Now, whoever designed this thing went to a lot of trouble to make a cast body. There looks to be like some decent hardware in there. It doesn't look like the kind of build that would have this sort of sloppy function. And this behaves exactly the same way in my part, because my part is exactly the same, thank you very much. But I'm getting ahead of myself. It's not really my place to figure out how or why this thing works. I was just supposed to shut up and fix it, Tony. Which takes us to the elephant in the room, the brass oiler. Not to be confused with the badass oiler. Don't ask me how I know that. This little doohickey is for getting oil into the slidey bits. Here it would send oil onto the detent lug. Mechanically it works exactly like the spring detents I've been yammering on about. Only in this instance it works as a check valve. You can squirt oil in, as the oil can, let's say, would open the ball, but oil couldn't get back out since the ball is spring-loaded closed. These things are used all over the place. My lathe alone has about 4 million of them. So no, I didn't forget about it. It wasn't an oversight. I didn't install one in mine simply because I don't have one to put in there. Now, to install these, you just drill a hole the right size and push the oiler in. It's an interference fit. Now, I could likely dig out the old one and reuse it. Maybe drilling a hole through the opposite side and tapping it out with a punch. And if this were mine, that's exactly what I'd do. But this isn't mine. And dollars for donuts, if I returned the old part in any condition other than the one I received it in, someone somewhere would complain that they had other plans for it, or nobody asked me to, or you name it. Not to mention, this oiler's never been used. This was covered in a golden brown wooden crust of sawdust and glue and who knows what else. The oiler has no signs on its face of being force-fed oil with the wrong oil gun, which, let's face it, they always do because no one ever has the right oil gun. The inside was dry as a bone, and there's a lot of fretting, the kind you'd expect to see from dry steel on aluminum bearing surfaces. Of course, in all seriousness, you wouldn't omit a feature like that. If you were running some kind of job shop or maintenance shop or doing this for a living, once you touch the part, everything about the part becomes your responsibility. Bottom line, in my case, it was more trouble than it's worth, and I rationalized myself. I told you you're not getting it for Oh, honey, I'm so sorry. I thought... What kid? I'm all done here. I was ready and I'm on my way back in. Oh, hey, baby. One more thing. Thanks for watching.